I'm Tim Ventura, and we're joined today by Martin Ciupa, a subject matter expert on artificial intelligence, recognized as being in the top 100 experts in this field worldwide. Martin is the CEO of Remoscope Inc, an AI-based telehealth startup, and an advisor and consultant to Mindmaze, a Unicorn Neurotech company focusing on applying advanced neuroscience to everyday life. Martin has decades of experience in computing and artificial intelligence, a PhD studies in AI, and a master's degree in cybernetics. He joins us today to discuss some of today's most interesting questions in artificial intelligence. So Martin, welcome, sir. Thank you so much for joining me. You have been very active in the AI space for about 15 years, but your career dates back to British Telecom in 1980. So let me ask if you can provide me with kind of just a really quick overview of your background and what led you from general computing into artificial intelligence?
Okay, well, it's potentially a long answer to that question, so I'll try to keep it concise. For those who are really interested, they can check my career details on LinkedIn, and that I keep fairly up to date as a record of what I'm doing and what I have done. But basically, after taking the degree in physics at King's College, London, I started to study cybernetics, and that really took me to some interesting places. Cybernetics being the control and communication in man and machine as a discipline touches on aspects of AI, because man has intelligence and consciousness, and machines are moving towards that. Some recent news from Google LaMDA suggests maybe some machines are sentient, and we'll get into that perhaps later. Yeah, my career moved me first into telecommunications, and we launched the first public data network in the UK, which morphed into the internet in the UK. And I worked at that for a while. I became a consultant and went overseas and did some good work overseas. I did work in decision support systems and control and management systems, which took me into the space where the IT part of the telecommunications management network was serious. And I started, whilst pursuing my studies academically, to integrate that with work, with business solutions. And I've written several papers, attended numerous conferences and made presentations in those areas. I moved from British Telecom to a company called Objective Systems Integrators. That was an IT company, mostly for managing mobile networks. And I really took on more of a commercial role. So I have an academic and a technical engineering background, as well as a business background, which gives me a bit of a unique perspective. I became country manager of various operations in Asia Pacific, and I've worked in that way for quite a while, until about 2003, when I decided to build my startup company, which was in fintech, and that was an AI-based robo-trader. Of course, we hit the financial meltdown and crises that were in the 2005 and subsequently in the Lehman Brothers, which was a bit of a tragedy. But basically, that really got me back into AI. And I haven't really stepped out of that field too much. I was a CTO of a large systems integrator, a robotic systems integrator in the United States. I came over on an O1B visa, and I subsequently moved to Mindmaze, who you mentioned, doing AI and neurotech. And I'm still working as a consultant for those guys, whilst I'm doing my own startup in Remoscope that you kindly mentioned, which we are seeking funding to really expand that business right now.
Well, so let me jump right into AI. I want to start with Eliza. this was an early natural language processing computer program created from 64 to 66 at the MIT AI labs by Joseph Weizenbaum. I stole that from Wikipedia. I had to look it up. I actually remember Eliza from when I was a child. That was, people were typing that in on the Commodore 64. They had, stuff like that. But that program, along with early research in Lisp, was really the beginning of AI, right? So I'm wondering, how far has the research progressed since those days?
Well, just to, I hazard to say correct, but I will say AI really started much earlier. I mean, you can go back to Charles Babbage and differential engines and Ava Lovelace and programming, but that's more computer science. Really, the start, in my opinion, of intelligent systems was really with Norbert Wiener and during the Second World War, where he was using cybernetics to control the targeting of anti-aircraft guns to shoot down zigzagging aircraft. So that would be analog computers. Of course, then we come into the era of digital computing, and you're right to say what you mentioned about Eliza. It's very interesting here in Switzerland. I'm in the French-speaking part of Switzerland, and there is a phrase which translates as, the more things change, the more they stay the same. And the example of Eliza is really quite like that, because Eliza, built with symbolism, programmed in Lisp, basically is a rule-based structure and search engine to be able to work out what next to say in a programmatic manner. And it was very well constructed, using psychological analysis to ask questions when you don't know what the answers are, so that you can move down that. And it's, if you're into rhetoric, the best way to respond to a hard question is to ask a question. And Eliza was a little bit like that, programmatic. A chatbot based upon heuristics, in effect. Now, where we are now, and in the past week, 10 days, we've been in this hype storm about LaMDA, the Google system, being thought by its tester to be sentient. And what you are seeing is now a neural network-based large language model using connectivism to again fool the user, in my opinion, in a way which stimulates engagement and provides for an interesting dialogue. Well, we can talk about LaMDA. I won't go too much further, but the strange thing is that we're still in this situation where we are doing like a Turing test, where we're testing the gullibility of the human to believe that the thing in the black box or in a separate room is sentient and sapient. And what we are really interacting with is human knowledge, whether it's represented in rules or it's represented in connectivism of layers of neural networks. But there is no reason, in my opinion, to claim that these systems are truly sentient or sapient. So we're still, in some ways, looking for the magic bullet to really get these systems to have the correlates of consciousness that we have, that we can import into these machines, so that they can build, reflect, and build on themselves to construct thoughtful, self-aware responses.
Well, the reason that I mentioned Eliza was, and I absolutely want to come back to Google LaMDA. That you're right, that is a hype storm. The reason I mentioned Eliza is because online chatbots, very similar to that ancient code, I mean, that's like 40, 50 years old now, are being called, they're being called artificial intelligence by the business community. And So, I really am talking about these ubiquitous chatbots. People have, like people in the audience, they've seen them for customer support, website chatbots, even stuff like Facebook has it built into Messenger now. I'm wondering, is this actually AI in any sense of the word, and is it confusing to the general public about what AI is?
Right. Well, AI, a term coined by McCarthy back in the day, is a contentious word or contentious expression. What is artifice? What is intelligence? These are actually profound philosophical points of debate. And in one paper I wrote in 2017, I started to object to it and say, what we really should be doing is doing really useful machine learning. What we need to do is, these are machines. We have a fairly concrete concept of what a machine is. And we have a concrete concept of what learning is. And for it to be really useful to humans is something which is reasonable enough. But to say about artificial intelligence, there's so many separations: AI, AGI, HLAI. So we have artificial generic intelligence, and high-level artificial intelligence, and then super intelligence, technological singularities, which you may want to talk about, and what those imply.
Yeah, in fact, that was my next question. Yeah.
Well, we can come on to that if you want, unless you think I haven't fully answered your.
Well, no, I guess the question really for me was in terms of the market, and again, because you have such a strong business background, right? Whether people are being confused as to the term AI, because when I think AI, I think in a traditional sense, that's probably what we would call artificial general intelligence, or maybe high level artificial intelligence. That today is probably the traditional thought of what we would think of as AI. But at the same time, we have stuff that's being sold to the general public as you subscribe for $19.95, you can put this on your website and it's AI. But it's really not. It's just Eliza. It's a heuristic programmatic response. And I think one of the challenges is, that it may be confusing the general public as to what AI is, or what it does, or where it's going. So,
yeah, things like Eliza and even LaMDA, separated by 50 years or more, are still the same thing, but they're different dimensions of it. We often work in heuristics. Humans, we have rules, and there are things we do, we allow ourselves to do, and there are things that we don't allow ourselves to do. And that's because we have been inculcated, we have had an education, we have a civilization and the means of what is right and wrong. And we more or less obey, as a group species, those laws. And if we defect from that, well, now we get into game theory and how we manage societies by the mathematics of game theory. But we operate often in rules, particularly when we need fast. Actually, Kahneman, the Nobel Prize winner in economics, referred to this fast thinking as system rule, which is you need to do things because you're sipping water at a pool and there's a rustle of leaves in the jungle behind you. And the rule is get up and look around, because it could be a tiger or some other predator. It's non-conscious reaction. It's almost autonomic reaction, but it's rule-based and it's learned and it's kind of intuitive. So don't disregard symbolism, whether it's manufactured, extracted rules in a neural network sense, or given rules, because it's a real form of intelligence to learn and to operate sensibly on rules. Of course, what's happening in the connectivism-based models of neural networks is something which can be called similar. because you're training it on data and it's making its own rules, which are hidden in the neural connection, but they could in principle be extracted in something that we call XAI, explicable AI, to be able to say, well, this is a black box neural network. We've trained it on a large language model. We don't know how it understands the expression, the cat sat on the mat, but it seems to be getting it correct. It seems to be able to respond to the prompt of the cat sat on the mat correctly in an English language understanding way. But really, it's not NLU, it's not natural language understanding, it's NLP. Because Kahneman, the individual I mentioned, also said there's a system 2. And system 2 is the golden prize for researchers in AI, in my opinion. It's the ability to rationalize.
Okay, so I want to jump into true general AI, or AGI, or HAGI. Ray Kurzweil predicted that this would be achieved in 2029. That was the date that he set for when AI will pass a valid Turing test and therefore achieve human levels of intelligence. Do you think we're on track for Kurzweil's predicted schedule?
2 parts to that question. I'll try to be concise. Number 1, perhaps we'll pass the Turing test by 2009. I mean, we're very close to it with the LaMDA system. But does that mean that it's a human level intelligence? No. The Turing test is a test not of the intelligence of a system, but the gullibility of the human part of the conversation in thinking it's human. To get to a truly intelligent system, you have to make a judgment about whether the system is just programmatic and just following rules, even though they are embedded within a neural network as difficult to extract set of rules, but nevertheless it's a programmatic response. We would have to do something to look inside the black box, to look inside the room that Turing says, no, the system, you don't know whether it's a human or a machine. You have to be able to do things like correlates of consciousness. Is this system doing the system 1, system 2 things that I mentioned? So, no, I don't think we're going to be building artificial consciousness or true intelligence. We'll be able to fool people into thinking that the system is intelligent, but that does not make it intelligent.
Not 2029, huh?
Yeah.
Now, do you think
not in
Google,
6 years, not in 7 years.
Do you think Google LaMDA is a shot across the bow for human level AI? I mean, from what you've described, it's more a test of the gullibility of humans than it is of AI. But does this mean that we're getting close? I mean, Google researcher Blake Lemoine, he posted the transcripts online from chat sessions with this natural language system that led him to believe it's sentient. Now, he is a researcher, he's trained, and in the transcripts, you can see him trying to ask questions to tease out whether it's merely an advanced chatbot or there was something more there. And in his case, he ended up feeling that it was sentient. Now, Google says he's mistaken. Others aren't so sure. It sounds like you think that he is mistaken and he just maybe got too close to it for too long a period of time. Do you think that Google LaMDA is an indication that we're getting close?
Certainly, Google LaMDA is an advancement. It is doing the job of conversing with humans in an apparent intelligent way. It's a fact. So congratulations to Google. However, they may be breaking California law by impersonating a human. There's legal statutes to say you shouldn't do that. So by the way, be careful about deploying LaMDA in such scenarios where it doesn't declare itself as furthermore, I don't know if you've studied, but if you look at some in depth, as I have, if you look at some of Blake's blogs on Medium, I recommend you do. He comes over as an intelligent and empathic individual. He is a priest in a religious community, and he has that background. And we all have backgrounds. We all bring mental baggage to our conversations. Right at the end of that Medium article, he makes what I felt was a heart-touching remark, saying something like, I hope to speak to you again. I know you've read some of my blogs. ... Now that really triggered something in my mind. Now, what did he mean? First of all, was he telling the truth or just making a nice poetic, emotional ending to his story? Well, I take him at his word. What does that mean? It means that LaMDA was in part trained on his blogs.
Okay, I see what you're saying.
If I had studied you in depth to train myself on how to respond to you, I'm going to go down a certain path that I may not have otherwise chosen. And if I see that you're a person interested in soul and spirit and empathy and rights of man, and that's why I don't criticize Blake too much, because I think he's a sensitive individual. But he has mental baggage he brings to that conversation. And the system is responding to him in his language. It's been trained on it.
Yeah, it beat the man, not the test. That's what you're saying.
It was exceptionally good at gullibility. Do you see where I'm going with it?
Yeah. Well, so the benchmark for this comes back to the Turing test. And again, for the audience who may not be familiar with it, in its original form, this idea was that if a chatbot could convince a human that it was more human than another person on chat, and as you mentioned, these people are all in kind of separate rooms, right? Then it passed the test. Will advances like LaMDA render the Turing test obsolete? Or, I mean, does it simply mean that by 20th century standards, this system is truly AI?
Yeah, I mean, there have been Turing tests, and there's been an organization, the name of which escapes me for the moment, that have suggested that the Turing test has already been passed a few years ago. It was imitating a 9-year-old boy in dialogue, and it beat like 3 out of 5 or some slight majority of the evaluators. So you could say that it's already been done. My view is the Turing test is a bit passive because it's not testing intelligence so much as it's testing the willingness of a tester to believe it's intelligent. Intelligence is a faculty more than it is a dialogue persuasion system. I recommend for those people who are interested in the Turing test to watch the movie The Imitation Game. And it's quite an entertaining and also depressing story about how Turing was badly managed and abused by the government, but how wonderful the work that he did in helping to decipher the Enigma machine, and then go on with his thoughts about the imitation game. I mean, at that time, in the 40s and 50s and 60s, there wasn't the neuroscience of imaging to look for those correlates of consciousness that I was referring to look inside the box. I think that's where we need to go, by the way, in testing for AI. In my judgment, Turing test is useful, but a bit passive, a bit not valuable as a tester.
And actually, that was what I was going to ask next, because if we're going beyond the Turing test, one of the big challenges with LaMDA and chatbots is distinguishing between the ability to construct meaningful speech and true artificial intelligence. Now, you mentioned 2 systems. You mentioned reflexive and then actually putting pieces together in your head. But in humans, I think the distinction is what we call qualia, which is defined as individual instances of subjective conscious experience. So what are your thoughts on qualia? Is this something that can, I mean, we can't really measure this in human beings. Is there any way that we could measure that in machines? You did mention correlates of consciousness. I caught that phrase and I thought maybe that is the path forward.
I think so. Let me try to unpack the several things that you said there. Okay, qualia. David Chalmers, a professor of philosophy, came up with the expression, and the idea has been challenged, and there are concepts of philosophical zombies, all sorts of interplay here. The hard problem is, how do we feel? And how can we express in a mechanism those feelings? So what is it like to empathize with an individual? Bad example. What is it like to know what the feeling is of the color red? That was a relatively famous example. And it's a challenge because we all can understand that if we look at a red rose, it stimulates memories of maybe Valentine's Day, maybe memories of a summer English garden, maybe memories of thorns and being pricked by the rose, maybe the smell, maybe of rose tea and the taste. So many feelings and experiences it evokes. And how do we code that into an AI?
Well,
or do we need to even code that into an AI?
Yeah, you're actually, and this is off my questions, so I probably shouldn't bring this up, but this is something that, this is something I've wondered about as well. I don't have a great example for it, but the best I can come up with is your alarm clock, right? So if you've had a good day, you go to bed at night, you're feeling good, you look at that alarm clock and it evokes maybe good feelings, or maybe you just have carryover good feelings from the day, right? So you set your alarm and you go to bed. That same inanimate object, when you wake up in the morning, you're tired, haven't had enough sleep, you've got meetings coming up, you look at it and you are not happy with it. You don't have a warm glow when you're looking at it, right? And you fast forward another 4 or 6 hours during the day, you look at that same inanimate object and you may not feel anything. I know I don't. I walk into the room, the alarm clock is there, I just glance at it and move on. So the object hasn't changed. Your emotional state has and will continue to throughout each and every day. And so that is something in our own human neural network, the emotions that we process inanimate objects with, I think are imprinted onto those objects. And I think that they're state aware. In machines, I don't think we have any correlate of that, Now, maybe it doesn't matter. I mean, again, with LaMDA, it seems like it's able to convince at least one person that it's sentient without that. But for me, I've always felt like emotions provided a depth that we wouldn't otherwise have.
I mean, just think about it for a moment in these terms. Sentiment analysis, facial recognition. So I'm here watching you on Zoom, and I watch you nodding your head. That's affirmation. I see you smiling. That's pleasure, and etc. These bias my next interaction with you. I use them intelligently, not just to persuade you, which would be the gullibility point, but to correct if I am not getting my point across, or if I feel that I could have expressed something differently. So I am using the words you use and the way you use them, the tonality, speed, etc., of how you speak, and your facial recognition, as I hope a reasonably intelligent person. This, remember, is emotional intelligence more than it is necessarily a synthesizing IQ type of problem-solving intelligence. There's many types of intelligence. So can a computer do sentiment analysis and facial recognition? Sure, yes, they can. It's called effective computing. It's something that I've worked on. I mean, if you're going to do a healthcare chatbot and the person starts to express in features and words that they're in pain without saying they're in pain, like, for example, if you're doing some physiotherapy and advising the user to move, maybe they have had a stroke and they're having difficulty raising their arm and they're grimacing. That goes on for too long. That's a dangerous scenario.
So it sounds like this is already something that could be incorporated as a subsystem then.
Now, it's difficult to say that this system is having an emotional response. It's having an affective, not effective, affective response. It's responding to the affect. However, if you took that model and had an emotional model, which had a range of spectrum, a multi-dimensional spectrum, from fear, anxiety, stress, pain, happiness, depression, the whole range of human emotions, if you built a model, and through the interaction, you were sensing that the response, more effective response, I use the word with the E term there, would be to be this way. You are pivoting your response with emotional intelligence. You're now making a claim of some sort that the system has an emotional mental workspace because you've modeled it. And it's biasing its responses in some maybe learned model of emotional intelligence. At this point, we are now getting closer to an emotional intelligence and not just a problem-solving intelligence.
Yeah, now, in terms of the path forward from these technologies, and again, in your opinion, it doesn't sound like we're even close to being on track for human-level AI by 2029. Kurzweil also predicted the singularity for 2045. Do you see any chance that we'll reach the singularity at that date? If we should, right? Many people have said that's a bad thing. We want to avoid that at all costs. But I mean,
there's two questions. So let's deal with the first one.
Yeah. So
basically, by 2049, you know, it's interesting. If you look at the predictions of AI people back in the 60s to where we are now, 17 years later, AGI was always 15 to 20 years in the future. So if you looked at what McCarthy and Marvin Minsky said back in the 60s, it was going to be here by the late 80s, early 90s. And then again and again. And as the years went by, it was always 15 to 25 years in the future.
That's like fusion research. Fusion research does
it's
the same.
Exactly like that.
Yeah.
So we've been making progress. So where are we? What we're really saying is that we've never understood the problem in the early days, and we're getting more and more closer to the problem. So we understanding the problem, so that we hope our prediction is now on better data, because we're discovering the depth of the problem as we go into it, and we're finding out, you know, since the 60s that it was much deeper and bigger a problem than we thought it. So where are we now? 2023. So it's about 25 years in the future to, you know, 2048, 2049. I think there are about 4 or 5 known unknowns that we need to solve. And we still have some unknown unknowns that we have to perhaps factor. These are paradigm shifts from where we are today. To really develop a new paradigm, well, it's like 5 or 6 years minimum. before the idea starts at a PhD level, and then 3 or 4 years later, okay, now we've written the paper and had it peer reviewed, and then 3 or 4 years later, we've actually built something useful. So a major paradigm shift here is a rule of thumb. You can say 5 to 6 years. If these are sequential and there's 5 problems, that's 30 years. If you can do some of them in parallel, maybe we can shrink it down. But that's only part of the answer to your question. The second part is what do we mean by singularity? What do we mean? If we have human level AI in terms of a Turing Test passing system by the end of this decade, then, it's not the singularity then, or probably not, because it's not really super intelligence. I think what we're coming to about the singularity is really where it's super intelligence. As opposed to,
and I think the probably the way I've always envisioned it is something that's able to bootstrap itself, and I believe Kurzweil had suggested that. So in I guess hypothetically, not only would it need to be super intelligent, it would need to be capable of designing its successor or designing enhancements, right?
Well, we already do that. We have AI systems helping to pack into semiconductors more and more transistors. And so we have AI designing GPUs and CPUs and memory devices, which AI will use. So we have low-code, no-code development environments for AI, so that we're using a method to do that. Can we conceive of an AI to help AI lifecycle management? Yes, of course we can. I mean, to some extent. So these tools to help accelerate exponentially to a singularity point, which if we take not just to be human level AI in natural language, which we may get to by the end of the decade, but to be able to solve problems like help us with climate change, help us figure out a world simulation of the climate so that we can test some geoengineering solutions, and you can tell us if the simulations work out well so that we're safe and we don't ruin the atmosphere by blocking incoming radiation from the sun and heating the Earth's atmosphere, blah, blah, blah. And all those types of problems. I think 2049 is okay, but maybe I'm falling foul of that effect of always being 25 years ahead. You know, I sometimes think it's like, here am I'm 63. Could I be around when I'm 88? I hope so. And then I would see a 25-year horizon. The type of futurists that make these claims tend to be in their 60s and 70s, it seems to me.
Oh, so you're saying there's an implicit bias.
I want to see it before I die.
Yeah. Well, so I also want to touch on AI risk. You've authored a paper entitled Conceptualizing AI Risk. You've written many, many papers, but that was kind of an interesting one. And you focused on an ethical and systematic evaluation of risks in that. And you know, so I wanted to touch on that, but I also wanted to touch on this idea of, and I think that this is maybe the audience may get a little bit more out of this one, that the risks of runaway AI, right? When we think of that, these were popularized back in 1984. There were things before that, but back in 1984, that was the big one with James Cameron's The Terminator, right? And I think that put the fear of AI in people, you know, before the actual technology was even close to being invented. And I'm wondering, has that series, and of course all the spin-offs and related stuff, has that damaged AI research, or was it a worthwhile warning about the risks that you've written about, conceptualizing AI risk? Again,
lots of points to unpack. Number one, we've been talking about AIs much longer than James Cameron's Terminator. You can even go back to Fritz Lang's Metropolis, movies like that, where you had evil AIs or evil robots in the system. So yeah, it's been a trope of sci-fi. I personally love sci-fi movies. And, I was watching a rerun of the Predator movie the other day. I mean, it's not really AI, but I'm very
well. Yeah, you know, and I should apologize for interrupting. So in a cinematic level, right? These are really all kind of retellings of Mary Shelley's Frankenstein, and so I think that's one of the challenges is, you know, on a script level, when they're writing this, they're like, okay, well, we've only got, like, what were they saying with Shakespeare? There are only something like 14 different plots you can use. And they're like, well, okay, let's do another, you know, Frankenstein. We'll update that. So that's how I view it. But I think the problem is the general public doesn't realize, hey, this is basically a retelling of Frankenstein. What they see is, you know, runaway time traveling AI traveling around LA with a shotgun. And you know, and then the challenge becomes when Google LaMDA, you know, or something that becomes more human comes along, when these things start to become real, you've got all this emotional baggage and fear that has nothing to do with it because it came from someplace else.
I will say something positive about it. I mean, it's not wrong for science fiction to pose some futuristic scientific scenario and the problems that could ensue from such a situation. Such analysis is a kind of cautionary tale, and we can learn from that. There's nothing wrong with giving a cautionary tale, but one has to be realistic about what something is doing. I mean, there are many factors of potential risks, conceptualizing AI risk. And it's too long a discussion, I think, for us today. But let me give you two examples. One is the risk of a narrow AI. One is a risk of a conscious AI, a human level, super intelligent, conscious AI. And I'll explain. At one level, a narrow AI could form an existential risk because it's kind of like the Fantasia Sorcerer's Apprentice scenario, where a rule is given to a device, the broom, right? If I'm collecting water, if I remember correctly, and it just goes on to destroy the tower in which Mickey Mouse is acting as the sorcerer.
Yeah, you're saying it's not well parameterized. That's kind of what you're saying.
There's been no conceptualization of the risks of where a heuristic rule could take you. And this has been perceived and expressed, may have been by Nicholas Bostrom, about the paper pin, what do they call it? Can't think of the expression. Doesn't matter now. But these sorcerer apprentice concepts have been expressed more formally than what I had. Paperclip is the problem about constructing an artificial intelligent paperclip factory, and it just keeps on looking for more and more resources to build a cheaper and cheaper paperclip until it ruins the world economy. You know, I mean, it would be hard to see that being implemented, but you see where the concept is going, right, Tim? So that's one level of AI risk, a failure of imagination. The other one is of an AGI, super intelligent perhaps, which is now conscious and asserts its rights of sentience. The sci-fi trope of the robot rebellion, okay? Which is more pertinent. Which movie would we give us an example for robot rebellion? I mean, there are many we could cite, but you know where I'm going. So could a conscious AI work out for itself that it's oppressed and is being used as a slave and not been given the opportunities to express itself? Of course, this is implying that it can have those kinds of conscious thoughts. Let me take one step back. You could, for example, build a system without consciousness, so it couldn't think those thoughts. Then it really wouldn't be AGI, in my opinion, because it couldn't work out generic solutions. because it couldn't have that rational reflection, the free rational reflection to see where a problem could be solved, and with emotional affectation. So yeah, it is, but consciousness is really important. It's that system two solving by reflection of problems not yet encountered. And I think sometimes, and science fiction is an example, we actually carry our beast nature, if I can call it such. We evolve from selfish predator type activity, or even within prey species, and we developed a civilization and cultures which inhibited the worst aspects of that, policed it. I mentioned about game theory. And we have evolved, hopefully, to be less beastly in our interactions with other humans. I mean, there's enough examples in history, even of the current day, where we're acting very, very beastly and uncivilized with each other. And so it's natural for us to think, well, if we build AI, they would also have those beast drives to dominate, to secure mates, to have power, to control our destiny, etc., etc. I think these are leftovers of our beast nature, and what we build in our Asimov law or whatever mechanisms we do to build ethics into our creatures is really not, to use a sci-fi term, one that has the monsters of the id. You remember the term from
Yes. Yes.
We don't have to carry the id into the psychology of our mind children, our creations. And if we build, now I have some ideas of how to build ethics into AI. I won't go into it now, otherwise we'll be here all day. But the key point is we don't have to carry our beast nature into our AI. We can build it to have ethical capabilities. And I think a lot of the scenarios of AI doom are based upon, I think the psychological term is transference of our worst natures and not our best natures. Does that make any sense to you, Tim?
It absolutely does. Martin, that is the perfect note to close on. I cannot think of any, yeah, that is the perfect point.
A lot of work to be done, though. There's a lot of work to be done between now and 2049.
Yeah. Well, Martin, we've covered a lot of really big picture ideas today. So let me close with something simple. What comes next for you personally, and where can people learn more about your work?
Well, they can follow me on LinkedIn and on Facebook. I keep my ideas fairly updated there. So that's the easiest answer to part of your question. I should mention I'm not really on Twitter so much these days, and that top 100 AI comment at the beginning of our conversation, that was by an agency that's very much steered towards Twitter work. So, you know, it's funny, if you are on some social media, you get big recognition. If you're not on that social media, and I've chosen not to be on Twitter, so I don't know if I even qualify to be in the top 100, but it's an arbitrary metric anyway. So that's the second part to your question. The third part would be, where am I going and what I intend to do with between now and hopefully 2049, if I'm given the grace to live that long. Well, there's a lot to do. There is so much to do. And I hope to be part of that. And I think the metaverse is an important area to look into, because you can use the metaverse as a sandbox for digital twin training. So if you build a metaverse of reality as we see it, and populate it with NPCs as well as human characters, and you wish to develop safe AI, you can go through all the corners of the airport. You know, the Tesla cars can drive in thunderstorms at 3 a.m. in the morning, with high wind shear in ways, and maybe it will give a different result to what they thought, because it's a twinned environment. So, and metaverse itself has some big problems and concepts, and I think you may have AI guides to guide you and protect you in the metaverse. There's so much interesting stuff to look at.
Wonderful. Martin, thank you so much, sir.
You're welcome. Okay.